Okay, and this time I'm really here. I thought I was here previously, and it turned out that StreamYard had some error, and I had to exit the studio, reload it all, and then it started working again. Thanks for your patience. How much time have I wasted? 9 minutes. Ah, yes. Audio. Okay, can you hear me now? Yes, audio. This is the problem when I use a tool that I haven't used very often, and yeah.
in the ghetto said you're traveling through another dimension. A dimension not only of sight and sound,
that's going to be a long chat. Hang on.
of imagination. Your next stop, the Twilight Zone.
Okay. That might be a problem when I'm doing the interview. Speaking of which, I have a returning guest on here today. You have seen him before?
No, I can't hear you.
Oh, Peter, stop it. Okay, I'm going to bring Josh on right now. Get straight into this. Okay, Josh, you're back. We're back. I think we're on the air.
It's like we've had this conversation before.
No. We were talking for several minutes until I realized that StreamYard was not actually connecting to YouTube properly and was coming up with some error.
That is going to be very annoying.
I know it. Trust me. Yes, I am going to mute that now. Sorry, Mitchell. The text chat feedback is very cool, but in this situation, when we're trying to have a conversation, I think it's going to drive us insane.
No. John and I were. We would have gone the entire 2 hours without realizing.
Oh yeah, absolutely.
We would have gone the entire 2 hours without realizing that we were not live. So it's a good thing we noticed that.
Yeah.
Before we start, I will just say I can't see the chat. So if someone says something, I'm not ignoring you. I'm sorry. We'll catch that up eventually. And also, I'm going to say my Wi-Fi's been a bit dodgy the last few days. I do have a patch cable plugged in to a network point, but that's on the other side of the room. And because I'm going to be walking around, I know I'm just going to trip over it if I bring it out now. So I'm going to wait till it goes wrong. Then I'll bring it out and plug in. So if I suddenly drop off, I'll be back. Don't worry.
Yeah. And we all know that I can talk for 2 hours straight on my own, so it should be okay. We can cover any little gaps. So many of you will have seen Josh before as a previous guest of the live stream. And on the previous episode, we were talking about some of his home automation projects. He's built many little boards and things.
I'm going to plug that patch cable in there.
Oh, okay, looks like Josh is having some Wi-Fi issues. So, muted feature added, says Mitchell. Mitchell is live updating the chat voice feedback system. And on the previous episode, we were looking at some of Josh's home automation projects. But a little while ago, he sent me some photos of a robot, a semi-humanoid, half a humanoid robot project that he's been working on for a while. And it looks really, really interesting. So I wanted to get him on to have a talk about that. We're going to see it for real in just a moment. But first, I wanted to know, Josh, what's your motivation for having begun this project? How was it that it came about that you wanted to build a humanoid robot?
So this particular project was done as my major project for my degree. So I guess there's two bits of backstory I need to give. One is my interest in robotics, but I'll do the quick one first, which is the degree. I've just graduated from product design, Bachelor of Science degree at Nottingham University in Nottingham in the UK. There's 3 product design courses. So I did product design BSc, which is Bachelor of Science. Then there's product design Bachelors of Arts or BA, and then furniture design BA. And 3 courses were grouped together. So we did the same modules with the exact same mark scheme, but we were graded based on different criteria, if that makes sense. So BSc, my course, we're technical designers. BA are product designers, and furniture designers.
I really like the sound of that combination of the 3 courses, because you're approaching a problem from multiple ways. You've got the technical side, the design side, but you've also got the fabrication side where you can be hands-on. So it gives you the skills you need to actually build something physically as well as designing it. And all of those things play into each other, and strength in one makes you stronger in the other, in my opinion.
Completely. And it was quite interesting because the course is either 3 or 4 years long, depending if you do a year in industry. So in the UK, a lot of courses, they call them sandwich courses, because you'll do 2 years of study, a year in industry, and then a final year of study. Now, so I did that, the sandwich, which means I did 4 years at university. Now, our first and final years for all 3 courses were near enough identical. We did the same modules, different projects in the first year. It's more self-directed in the final year. And then the second year, to be honest, I couldn't really tell you what the other 2 courses were doing, because we were on Teams the whole time because it was lockdown for us.
It would have been right in the middle of that period.
Yeah, so out of I think the entire university year is something like 36 weeks long. I think I actually stepped foot on campus less than 14 days. So yeah, we were all online. But to be fair, I have to give credit to my uni. They managed it pretty well. And I think apparently my university was already looking at going to blended learning. And they had a 5-year program to do it. They just had to do the whole program in a week when the lockdown hit, to get everybody on. But yeah, so in the final year, we have 3 projects: the minor projects, the major projects, and the dissertation. Minor projects, which they now call the commercial project, is they give you a brief. You have 5 briefs to choose from. You choose one and you run with that. That was that. The major project, which is now called the self-directed project, is within reason. You can do whatever you want. So I made a big robot.
Being ambitious.
Well, I said that to a few people, and a few people did look at me like, "Are you sure?"
Are you sure?
And then I'd say I'm making a robot, and they go, "Oh, cool!" And they think I'm making your classic robot kit. That's, a car that you'll build maybe with an Arduino or something like that, drive it around the tabletop, and then there you go. And I said, no, it's going to be about my height, and it's going to move, and it will be able to track your face. And they go, "Oh, cool. Project's 4 months, Josh." Yeah, it'll be fine. And many, many sleepless nights later it was.
Within the 4 months?
Well, so we have 4 months with the dissertation running in the background solely on the major project. But you can start your major project earlier. So I actually started it a year in advance.
Right, good.
Had I not done that, I would have been screwed. So I'm quite happy I did that.
Yeah.
And to be fair, the majority of the work was done within those 4 months. I managed to get sort of my background research and not so much my testing, but my initial designs that weren't probably ever going to go anywhere, but at the time seemed like the right thing out the way. Because I think anyone who's ever done any projects, designing, physical designing, circuit board, whatever, you'll know that the first idea you have in your head is not the one that is actually produced.
But you have to get past that, and that takes up time.
Exactly. And one of the circuits I'm going to show you today, which is in the unit, it had version 1.0, 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, and it's now on 2.0. So there's been 8 variations of that board. Some of them didn't even actually get to the point of being produced, because I was laying them out and it was going so nuts. I thought, no, scrap that, start again. So yeah, and I think anyone who's ever ordered anything from China can relate to this. I sent that board off to be fabricated, and by the time it arrived, it was already out of date.
Yes, I am familiar with that. And yes, there have been more than one occasion where I've had a board in fabrication and I've already uploaded the replacement files for the next iteration. And I'm pretty sure Austin has had that experience too.
I use JLC PCB for my board fabrication, and because what I do really like about it is when you submit an order, you can add more boards to your order as long as it hasn't been shipped.
Yes.
And I had on my last order a board on there, but it'd been made. I couldn't cancel it, but I knew it was wrong. So I've got 4 boards here. I mean, they're only sort of this big. They're not massive. But I'm like, I don't know what to do with you now. I haven't taken them out the packet because I know you're wrong. You were useless to me, but I don't want to throw them in the bin. So I'll find something to do with them, stick them on the wall somewhere, cut them up, make a big sign. I don't know. Yeah, I will also just say now, because I'll now talk about the robotics background. If at any point I mention, and this is for people because I know we've got viewers all around the world, my measurements are going to be in kilograms and mostly millimeters. And
Excellent.
if I say pounds, I mean British pounds, the currency. I don't mean mass. So I'm just gonna apologise now to anyone who doesn't speak those. I think it's about $1.20 to the pound if you want to do a quick conversion. If I say anything, and 1 inch is 2.5 is 25.4 millimeters. So there's your conversion there. So yeah. So the robot was completed for the degree, near enough. It was in my presentation. Because the presentation was only 10 minutes long with 5-minute Q&A, and I had to get it to the place, assemble it and everything, there wasn't sadly time to actually demo it during the presentation. But a few weeks later, we had our degree show, which is basically an exhibition of everything. So everybody had, I've got it here, this was the postcard with the robot on it. So that's a render with some information on the back. And this is our sort of, this side, our design school's sort of logo for the year, and add all of that. I'm not good with this mirrored thing. All of the information there. So it was a bit like an art exhibition, and you're going to see that. Now, to give a bit more context and background on the robotics, I've got 2 former robots here with me to show first. I'm only going to go through them quickly, and I've got a
So this is not your first project. This is not your first robot. It's okay.
I've got a USB camera on a tripod here. It's not the highest quality, so I apologise in advance. And I'm not going to spend too long on these 2. But we'll start with the first one I did. This one was completed it ran from September 2019 till March 2020, a month I'm sure we all remember very well. And it was completed just before Boris grounded everyone in the UK. And as soon as it was finished, I decided I want to make the second one. But we're going to start with the first one. Now, it takes me a second just to switch the camera over.
All right.
Can everybody see that?
I'm also going to try to figure out how to make you the larger. Hang on. How do I minimize myself? I'm going to try to figure out how to make you the larger one. There we go. Okay.
So you can probably see in the background as well, there is my refill oven. Might look familiar to you, John. Might have seen it.
It does indeed. Yeah, the 962C.
Yeah. I won't tell you how I decided to choose that one. But anyway. So this is the first robot I did. It stands 4 feet tall. Let's see if we can tilt the camera down a bit. It's on sort of an H-frame mild steel base that's been welded. The majority of the joints are done with these stupidly overpowered linear actuators. I think each one's got 60 kilograms of force. I do remember somebody telling me once, I bet I could stop one of those from opening. I said, all right, you put your hand on either side and we'll try.
Yeah, you try. Yeah.
Obviously, the actuator won. Now, the head, which was actually the first thing I designed that, funny enough, in bed on the computer one night. I just laid it out. And it was based on, and I'll show you this in a moment, this actually, which is a clock I designed. So it's got 2 boards in there. You know what? We'll save going over that in a minute when I go back over to the table and we'll have a look at that. But it's got an RGB matrix for its display. And you'll notice a resemblance.
Yes, I do.
It's got the exact same matrix for the eyes. And that's NeoPixels, WS28.
2812s or 13s. Oh, Josh is muted. I'm not sure why. Josh, I don't know if you can hear me, but you are currently muted.
Is that back?
That's back, yes.
So I picked up my microphone, and as I did that, I unplugged it. So Yeah.
So you're talking about neopixels. Yeah, so it's an array of
Yes.
neopixels.
I think it's 11 by 5 neopixels, which was designed originally to make a 7-segment type display.
Mm-hmm.
But that also makes very good eyes. But because you'd get bleed with the light between them, I 3D printed effectively a square grid, which sits on top, which is what, if I can just move my camera over to there, all these different parts are actually the build up of that.
Yeah, so it's a sandwich of all those different layers together.
Yes, exactly. And then in the back there is a DenScript Uno DIY. So those who saw the last stream will remember the DenScripts, which are my layout of boards. Now that is a DIY one, which is it's effectively meant to be a kit. It's basically an Arduino Uno, but it's got no surface mount components. In all honesty, I designed that because I was at university and didn't have access to a reflow oven and wanted to put it together. So that's how that was born. And then getting around the back is going to be a bit tricky here, so you're going to have to bear with me a minute. I apologize if anyone gets motion sick.
The video has frozen at the moment. That's back. Yep.
Actually, I can just flip it around. That's all right then. I've got it on some bubble wrap on the floor so it doesn't scratch it.
Okay.
But the back is an absolute mess of cables.
This is very impressive. That's a lot of work you put into this.
Thank you. So I'll say right up now, I'm not a coder. I think there's a saying I heard once, which is I can copy and paste well enough to make it work. And that is quite literally how I was with this. So just as an example, these actuators which allow the arms to lift up and down, they've got attached to them linear slide pots, and that was how I got my position feedback.
Right. So you've turned it into a closed loop system. That's really cool.
So effectively it was a servo is what I built here.
Yeah.
Now, at the time, my programming was even worse than it is now, and I wouldn't count it that great now, to be honest with you. So, almost as message. You're not far off, Scott. Now, so because I couldn't work out 100% how to get parallel tasking working on the Arduino, what I decided to do was instead I made these two stacks, if you want to call them that. That's effectively an Arduino Uno with a board which I call the dual relay motor driver, which is a long way of saying two relays wired together to allow you to turn a motor in two directions.
So it's like an H-bridge set up out of relays.
Effectively, yes. I could have gone and just bought an 8-bridge. Don't ask me why I didn't. And I decided to make that board instead. Now, the bigger board in the middle is actually... I'm not going to try and turn it around any further, but you can just see it here. This is 16 relays hooked up in pairs, so you get 8 outputs, all controlled by an MCP 23017.
Okay.
So it's effectively an I2C relay driver, but with relays in pairs, so you can turn motors in each direction. That does the actuators that let the elbows go up and down, and also does the actuators that are in the waist there. And I'm just going to turn it back around. I promise the camera work gets better.
Just while you've got it pointing down there, did you have to... There's a lot of mechanical fabrication in this. There was a comment earlier, David said, those bolts are massive. Are they 20 millimeter diameter bolts?
24.
24 millimeter. So
I don't do small when it comes to projects.
Yeah, I'm seeing a lot of welding, metalwork, possibly water jet cutting, those CNC machining. There are a lot of different things that have gone into the mechanical construction of this. How much of that did you do? Is this all your work?
So I was actually going to save this till we get onto the main uni project.
Oh, okay. Sorry, I jumped ahead.
You know what? I'll talk about it when I switch back to the face camera, because I realise right now you guys are just looking down at a robot and hearing my voice from the background. But I did have help with it, and I'm going to explain all about that in a moment. I'll just finish up on this quickly. But yeah, going on to that, the chest plate and this plate just down the bottom there, they are both water jet aluminium. The chest is, in fact, they're both 6mm. Then the rest of the main structure, so the spine, which you can sort of just see, might just be able to make out. I know it's quite dark in here. There, it's basically an H piece on its side, as well as the waist and the stand. That is all 40mm box section steel, cut, welded, and assembled together. And then the vast majority, as you can tell, was 3D printed. The biggest prints, actually, and these are two of the biggest prints I've ever done, were the shoulders. Each one's took 15 hours, and people have described it as looking a bit like an American football player.
Yes, with the shoulder pads.
So what I'll do now is I'll just switch back to the face camera. Hello. And I will explain about the background of where the fabrication came from. So at the university, we had the university workshop. I actually worked for my year in industry as a metalworking technician in that workshop. And I continue to do that part-time in my final year. Now, that workshop was incredibly well kitted out. So we had £100,000 when it was new 13 years ago, water jet cutting machine. For those who don't know what water jets are, it will cut through, the one we had anyway, will cut through any material known to man other than toughened glass and diamond. Diamond for obvious reasons, toughened glass because that's designed to shatter on impact. And what you're doing is you're cutting material with a 1mm wide beam of water that's traveling, I think, something like twice the speed of sound with 3,600 bar of pressure. So it's the equivalent of being something like 36 kilometers underwater, the pressure.
And also loaded with abrasive grit.
Exactly. So it's loaded with crushed garnet. Garnet's a semi-precious stone. It looks just like sand, but when you look at it under a microscope, it looks like a snowflake. So it's got those sharp cutting edges. It is single use, but because it's a stone from the earth, it can go straight back into the earth. It's not contaminating or anything like that. But that's literally it. So it's 3 high pressure pumps and it fires down. And that the one we had will cut through up to 150mm thick steel.
Wow.
Yeah. So an example piece we always used was, I kid you not, a block of steel about that wide, which was 100mm, and it cut through that. And we'd be walking, holding it like this, because it's only small, but it's solid mild
It's
steel.
so heavy.
It probably weighed about 15 kilos, that block. But it cut through that. Now, unlike something like a laser cutter or plasma cutter, where the thickness of the material will only slow it down a little bit, water jet cutting, because it's not a process where it uses heat or a laser to cut. It's actually having to grind through with the water and the abrasive. So that block I was telling you about, it actually only cut sort of a U shape about that big. Now, if it did that out of 1mm thick steel, it would just literally go like that, and it'd be a 10-second cycle. But doing that out of 100mm thick, it took 45 minutes because it's got to get down, down, and down. Now, the one we've got is 3-axis. And because of, if you think about water out of any tap or anything, it starts to spread out. And
so it's almost like having a focal point on a laser. You've got to get the height setting correct.
Exactly. So the newer ones, which are 4-axis, they have a head that will tilt. And that way, or there might even be 5-axis, and that gets rid of that spray, if you like. I don't know what you'd call it, but the conical shape, it removes that. The one we have, being older, doesn't do that. But to be honest with you, it rarely cuts anything thicker than 20mm. And even that is quite rare. I think the thickest it would do on a normal week would be 10mm. And you're going to see some 10mm stainless steel cut in the final robot, but that sheet was quite heavy to get on. So every time I had another one of those bits, there was 2 or 3 of us trying to lift that sheet onto the machine.
Yeah. Well, 10mm steel is an incredibly robust material. There wouldn't be very many situations where you need that sort of strength.
No. And I mean, we generally at the university we'd be cutting aluminium, mild steel, and stainless steel. Whilst I was working there, we did cut brass, and the thing about brass is just because of the cost of it, especially nowadays, since since COVID really, but it picked up beginning of last year. Metal prices have been so fluid, and they've been fluid, but they've only been going in one direction really, and that is up. And so we'd say to people, mild steel, stainless steel, aluminium have all got expensive. Brass was already expensive.
Workshop experience with
it. So I'll quickly mention the people I work with. So in the workshop there it was a team, if you like. So I was part of the technical team, which was then subdivided into labs, who mostly dealt with civil engineers. So as well as the stuff I'm talking about in the workshop, we had an 100-ton press that the civil engineers would crush concrete with and all stuff like that. And then so the labs team, and I was in the workshop team. On the metal side, I was with Steve and Alan. Both had done many years in industry before working at the university. So Alan was a tool maker. So he'd make, and that's not, by the way, spanners. That's injection mold press dies and stuff like that. So when it came to like working on a lathe or a milling machine, he'd just go at it and he'd be unbelievable doing it. Steve was a welder fabricator who used to work for Rolls-Royce in the aerospace division. So again, when he did the welding on the robots you've seen here, so he helped me out with that. And again, he was unbelievable. On the wood side, you had another Steve and Carl. Both of them they'd actually been to college together. Like in the UK, college is what you do between 16 and 18. Then you go to university. I know in America, what we call university, they call college. So just to make that
terminology.
Just do that terminology. And what often happens is if you're doing a trade, not so much now actually, it's starting to, how do I phrase this? It used to be if you were going to go into something that was a trade rather than, yeah, exactly, it's all about Steve. If you were doing a trade, you wouldn't go to university, you'd go to college and then do an apprenticeship. It then sort of switched that they were trying to push everyone to go to universities. And now that's kind of peaked and is coming down, and apprenticeships are picking up again. Just in the UK, it's how it's sort of been. But Cole and Wood Steve, they again both worked in industry for many years. Steve's primary job is as a woodworker. Cole, as well as being a woodworker, also operates the 5-axis CNC machine that the university has. But that doesn't do any metals, so it does woods, foams, and some plastics. But again, the stuff that they can make is unbelievable. As well as that, we had Graham, who's a store manager, and he'd worked at many companies in the past, including British Telecom, which is the main telephone company in the UK. And then we also had Jenny, who was another model making technician. So we had quite a big team in the workshop.
So this team of people presumably were there to assist all of the students, not just you, but it would have been your entire class. There probably would have been a bit of contention with everybody trying to get things done for their projects.
Definitely. So as I said, I was also for 1 year I was a technician as well, and then I was doing that part-time as well as my own degree in my final year. In a 1 year group, in one final year, typically you got about 200 students and 7 or 8 technicians. The balance isn't quite there. And also the workshop is limited to a capacity of 40 people just because of health and safety. So as always, I did see people cry because
frustration.
See people cry when I say, I'm very sorry, there's 40 people in here. You can stand right there and wait until someone leaves, but you can't come in. And it is sad, and I completely get it. And people got very protective over their spaces as well. If you were working at one table, someone else came over. I mean, I admit, I at one point I once said to someone, "What are you doing?" He says, "I'm working." I said, "Can you not see all my stuff's here?" I went, "Oh, I'm sorry." And I was like, I'm one of those people now. When stress hits you, everyone gets like that, and especially when it comes to the last few weeks, and people were working up to the wire and after it as well. So yeah, but that is where the fabrication and a lot of this happened. Now there are also electronics technicians, Sue and Matt, but the majority of the electronics people do, because we're a product design course, we're not an electronics course. They're not really at the level of the stuff that like you talk about on this channel. Yet we're taught Arduino, we're taught to program. Are people ever hooking up an Ethernet shield to a project? Probably not. They're making something that will light up some LEDs when you press a button, maybe send you back some serial data. The most complex project I helped with electronics, other than my own, was using an inertial measurement unit. So effectively an electronic gyroscope. And that was for a sports hockey stick tracker.
Oh, okay.
we do get some complex projects, but they're the highest level. We're not really talking about having to communicate between devices over networks and stuff like that. Very rarely do we have anything like that. And at the end of the day, which is something, you know, people say, I want to have my project work. And we go, it'd be great if it did, but we're a design course. In reality, you'd have a team of 100 people working on these projects. And you'd have the CAD guys, the electronics guys, the firmware, the app developers. You're one person who's got a deadline. And
yes.
I had to keep telling myself that as well. There's things I wish that this thing did that's under the black cover behind me that it still can't do. But we'll get onto that in a minute. I said I'd show you that clock very quickly. So I'm just going to plug it into a portable charger. It works on USB. It's got a real-time clock in it, so it with a tiny little coin cell, 3-volt battery, just to keep its timing. And obviously, it's going to be mirrored because that's how the vision is.
Actually, it might not be. We shall see. I think StreamYard shows it to yourself mirrored. No, that looks correct. 1:38.
That does look correct. So that is the time it is. In fact, it's running a little bit slow. Try and remember the buttons. So that one. No, that was hour. Okay, well, one of these buttons. There we go.
That's it.
That is the time it is in the. Well, it's not actually.
1:41 a.m.
It is in the UK at the moment.
Wow. Well, thank you for doing this late stream.
That's all right. But that is how the vision, the eyes of that robot worked. So before we get on to the big event, I'll show you one other quick robot. And so that first robot, I originally named it the Giant Robot because, as far as I was concerned, it was the biggest thing I'd ever made. Now, I was sitting there one day and I realised that GR isn't very good. So I wanted to give it a bit of a name. So I decided on Giant Robot with Electronic Gizmos, or Greg. I was probably sleep deprived when I came up with it. So that first robot was called Greg. Okay? The second robot, because I'm very imaginative, I named it Greg Gen 2.
Yeah.
I'm going to show you that now. Now, I was inspired to do this by another YouTuber who'd made a very tall, big robot. He released all his open source under GPL3, and he literally said at the end of his video, everybody else, go and make one if you can. You know, he said, so those who aren't aware of what the GPL3 license allows you to do, paraphrasing a bit here, you can replicate it, you can commercialize it, you can modify it, as long as you publish any changes and you publish the source. So that's what the license, in the gist of it, allows you to do. I didn't use any of his CAD, didn't use any of his code. He also doesn't do circuit design, and I designed all the circuits. And actually, when I was doing it, if you looked at two pictures separately, they look very similar. When you put them next to each other, they look completely different. But we'll switch over. I'm going to try and set up the camera. So
it was really a source of inspiration, but not derivation.
100%. And it's something I really recommend that, you know, if you're with someone here who's watching this and they get inspired by something I do, by all means, use it as some inspiration. Don't replicate it and put it off as your own work, though. And I think that'd be the same anywhere. And that is the beauty, I think, of the whole open source community, that anyone who's ever used an Arduino is technically a part of. So yeah, so what I'm going to do is I'm going to switch over now. This one did play true to the idea of the giant robot, because this is what we were just looking at.
Yeah.
And this is Gen 2.
Okay. It has grown a little.
So there's a height comparison.
Mm-hmm.
Just going to bring the camera up. So what does this robot do that's different? Firstly, I switched to actually using motors as opposed to actuators. The head is underneath the hood, if you like, of the head. It's exactly the same. So it's still got the LED grid, the exact same one, except I actually opted for using black PCBs this time, so make it a little bit harder to see. Thanks, Mitchell. It's also controlled over DMX. So you...
Oh, right, the lighting control system.
Exactly. It's a lighting control protocol. So in DMX and networks, which are called universes in the terminology, you can have up to 512 addresses. Now, that's not necessarily devices. So if you imagine an RGB light, that's one device, but with 3 addresses. This robot here has 30 addresses in it. So there's 10 for each motor. There's also 2 servos in each hand, one for the claws there, and another one that turns the wrist.
Yeah.
There's another 3 servos that move the head. And then you've got all the lighting effects. So the chest is actually hollow. There's a neopixel strip in there, and it provides illumination, so it almost looks like a heartbeat.
Oh, can you see through that? I can't really tell. Is that a piece of aluminium?
Yeah, so you've got 2 aluminium plates here and a gap with an LED strip here. I hope
Okay.
you can see what I'm doing. So you've got ball screws here, which these ball screws here allow the arms to lift up. These ball screws here, effectively you've got the universal joints in the middle, and by lifting one and lowering the other, it makes the robot tilt in one direction, tilt the other direction. If they both go up, it leans back. If they both go down, it leans forward. It's a little bit more back heavy than I would have liked, so I'm not going to lie to you. So when it leans back, I get a bit worried it's going to fall over.
The balance is a little off.
Yes, exactly. Most of the electronics are on the back, and to be honest with you, it's been gutted recently, and that's because I'm actually upgrading it with the control system in next gen, which we're going to see in a moment.
Okay.
What else to say? The power controls, or the power, is all on that MDF board at the back, and I'm going to see what I can. Well, actually, before I go on that, I also. Yes, that's correct. So you can have the software I'm using. I think by default it allows you to use 4 universes. I don't know if you can add more. I'll be honest, I've never had to go beyond 1, but it does give you that flexibility. I also made some other possible heads to go with it. So this is one that had.
At first glance, I thought it was something like a floodlight, but no, it's all RGB LEDs.
Bigger mouth, and then.
It's also very Bender-like.
Yeah, 100%. And then on the back of that are power supplies, your typical metal box, bent metal with your stripper screw terminals power supply that you get off Amazon or AliExpress or whatever else. That presented me some problems, and I'm going to go into that in a moment when we get on to next gen.
So Mitchell just made the follow-up comment. It sounds like Mitchell has a lot of experience with DMX. Said, I like the fact that it's using DMX since with lighting consoles, you can create scenes and flows so you can have it dance. Have a look at using a standard lighting controller. Easier to test with.
That's exactly why I chose it, because I'm going to just switch while we're talking, because it feels a bit odd. That's one of the reasons I chose it. As I mentioned before, I'm not the most confident programmer. And the thing I love so much about using DMX is the DMX software comes with a timeline. It comes with drag and drops. It comes with building scenes and then animations and stuff like that. So as an entry-level concept for education as well, that opens up so many possibilities, and I'm going to talk about that in a minute with the reveal here of next gen. So next gen, so we had Greg, Greg Gen 2, Greg
Mhm.
Next Gen. Now, I was told by a few people, try and not use the word Greg in this one. Just stick to Next Gen. So I went into the degree show, which is the big public exhibition with 2,000 people, calling it Next Gen. All
Mhm.
my friends who've seen me go on this mad adventure over the last 3 years said, Greg! And that was it. Everyone was calling it Greg.
It was great.
Now, this Next Gen ended up almost unintentionally having a throwback to the wide shoulders of the first one. In my initial sketches, it had this, the type of face we've seen already with the RGB matrix. We ended up getting rid of all of that. Before I show you, I'm going to just show a few things because I think I've discovered how to share my screen on here.
Okay. There are also a couple of questions I have in relation to the difference between the previous two robots that you've just shown us, like the changes in the motors. But maybe we can talk about that once you've done the big reveal, and we can talk about how you've done the mechanical side of it and the control side. All right, I'm going to add
There you go, yeah.
this. Yes.
So this, at the end of the last stream, I showed this image, almost foreshadowing. This is what Great looks like at the time. So what that is, that's a test shoulder with a test arm. I've got a bit of a habit of using orange if something's a prototype or a model. Don't ask me why, I just do. And that was a very good thing I did, because thankfully all of that was wrong. But it was the start. So that was the third shoulder prototype that had been done. The first two were made out of plywood that had been laser cut just to test sort of designs. I then went into making that aluminium one. The next version, which is very, 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 very similar to the final one, there were some minor modifications, saved about 50% of the weight off that version. So that was the key thing for me. I built this thing and this shoulder, and I realized the whole unit was going to weigh 100 kilos. Bear in mind, the tall one weighs about 70. And I thought, I've got to keep this weight down, especially because this one's now going to be interacting in public. And I was just thinking of it falling over. And I thought that, I'll make it impossible to fall over. But that one time it does, it can't weigh that much.
It'd be like a truck falling over. Yes,
Exactly.
and just the practicality of moving it around and being able to work on it.
Exactly.
If it's that heavy, you couldn't move it on your own.
No, completely. And also, people do ask me, even about the tall one, how do you get that to places? It's taller than the door to this room. So how do you get it out? And from the ground up, I designed these things to be portable. So on that last one you saw, the head comes off, the arms come off, the body, chest plate comes off, and its back comes off. And then there you go. You got it stripped down. Put the back seats down in your car, put it in, drive away. And bear in mind that all of these were designed and assembled in Nottingham. I'm now in London. It's a 2.5-hour drive each way. They've all made it down here. So that is possible. I will also just show quick. In fact, what I'm going to do is, because I can just see John, sorry everyone, this is a bit of a behind the scenes thing. No, sadly I can't. I wish I could. I wish you could walk, to be honest. That is one I'm looking at, because that would make my journeys a lot easier. I'm going to stop sharing that. What I'm going to do is I'm going to start sharing something else. But John, can you not make it visible yet so that I can just have it ready?
Sure.
Is that possible?
Yes, we're now off the screen with that.
Cool.
And also, I'll just make this comment while you're setting that up. There are quite a few comments from people that I have not brought up, but I'll probably come back to them, because I didn't want to interrupt your presentation too much.
I'm happy if we got some questions now, if we want to take a few minutes to go.
Yeah. Well, before we get into the reveal, so there has been a fair bit of discussion in the chat about DMX and people being interested in use of that. So Tradie Trev asked a question or a statement: DMX is more than sound and light.
So DMX is actually made for light. Sorry, I realised I didn't really cover that. Someone else, I think it was Mitchell, mentioned it before. DMX is a series of, effectively, if you're looking at it in the software, you're looking at sliders of values 0 to 255. So each one's 1 byte. And depending on when you move the slider, it sends that variable down. It's actually RS485. That's the physical hardware.
And the multi-drop bus, yeah.
And then it uses a protocol on top of that. in the same way that UDP or TCP is a protocol using the IP network, if you like. I know my terminology is a bit off there. We're going to run with it. Now, what these robots have done is they've taken that 0 to 255 value and they map that between, let's say, 0 and 90 for degrees. So if I'm doing my elbow, that could be 0, that could be 255, and it's just mapping the degrees. That's the way around it. So,
yeah, so even though most people conceptualize it as being something like an illumination level or for lighting, it's really just a value. You can map it to anything you like.
And it's interesting, the thing Mitchell just put up there, after I sort of worked out how to use DMX with Arduino and everything on Gen 2, I designed a small module, and those who are quite active in the Discord may remember about a year ago, I put a question in the general channel and I said, does anyone know the name of the enclosure that the Sonoff Basic is in? And someone did. It might have even been you, John. And I ordered 10 of them off AliExpress for about £1 each. And the reason was I designed a DMX module that literally had a MOSFET in it to dim lights. And that was the first version of a garden light control system that I did. So I just had these junction boxes with some metal conduit going, because we've got a dog, going around the garden. And in each one of these junction boxes was a DMX dimmer, if you like, with just hooked up to some garden lights. And then we just had a box where it plugged into an outdoor socket, ESP8266 controlling it. And that was the concept.
Yeah.
And
so
I think systems like Lutron, which is quite a big lighting company, don't think they use DMX, but I do know they do use something similar. So behind each light bulb, so if you imagine these spotlights here, behind each one would be a module, and you could then set up scenes where you'd individually dim light bulbs. So your high low mids, if you like.
Yeah. And there was a comment earlier. I'm just going. Oh, yes, this was in Mitchell's comment earlier, which I brought up. So it's just a standard. I think DALI was the industrial version for buildings. I've heard of DALI. I've never used it. I don't know anything about it. So, yeah, I am curious to know about people that have used DMX in home automation systems as well. Oh,
in my experience, I've never had it. Yes, you can do. So I tested using wireless DMX. The only problem I found with it is if you're not actually sending data to it, it just loses its connection. So DMX, and that's another thing to say about the protocol, it's not like other protocols where you send an update. So for example, the protocols I used UDP for my home automation system, and I just said that it would hold the last value until it got a new value. DMX doesn't work like that. DMX is always reading the line, and if no value is sent, it assumes the value 0.
Interesting. Okay.
You have to, if you change the value to 200, you have to keep sending the 200 value, even if that's not changing.
So it'll always fail in a safe state.
Yeah, which
is the idea.
Is an idea. And I guess looking back to its usage in theatre, for example, that might make sense in the event of a power cut or there was a failure with the control system. Let's say you had DMX controlling big features that move. You don't want suddenly an arm to come swinging down when you don't expect it. You want it to be set to a safe position. And I kind of get that. Obviously, since it's expanded out, it can get a bit annoying, but it's that whole back compatibility.
Yeah. Okay.
Should we do the big reveal?
Yeah. It's very interesting to see your use of DMX. All right. So you want me to just bring this up on the stream?
Yeah, you know what? Let's
click on add to stream.
I'm going to show it first, and then we'll switch to the thing I've got.
Okay. In that case, I will bring you up as the main screen and go for it.
I am already.
Yes.
Okay. There he is. The camera's gone a bit wonky. I do apologise. It is one of those cheap USB cameras, so it doesn't seem to.
That's all right.
If I lower one leg, I might be able to get it. There we go. So
Yes.
you'll
So
notice
this
the
is
3D
the
printing.
eyeballs.
Yeah.
I,
And I've actually got some spare eyeballs, so we can look at them on the table and see how they're made. But the 3D printing was lacking a lot more in this one, and we really hit the aluminium to town. So I'm going to move around a bit so you can see it, and there's some stuff on the screen down there we'll look at in a moment. But if we work just from the bottom up of the basic structure, the base, and you'll see there's a support pole running up the back, they're mild steel that have been powder coated black. So the base is wide enough to support it, and to be honest with you, when designing for a deadline, you kind of play it safe, and I didn't really know where the center of gravity was going to be, so I put the support pole in, and I'm really happy I did. And so that just acts as a third leg effectively. The legs and the feet are all made of aluminium that's been, you might be able to make it out there, it's been slotted together. So these are all flat sheets that have been slotted. And when I first pushed it together, so let's bring the camera down a bit so you can see. Actually, is this a quick, I've just discovered the quick release feature on this tripod. Right, so I'll try and be as steady as possible. But you can see
that's a good view.
A lot of the aluminium has been anodized. And when I first slotted it all together, and it was not anodized at the time, it looked so nice. I decided to weld it from the underneath because
right. Yes, you wouldn't want the welds to show.
I want to have seam lines and stuff like that. And you know what? I'm really, really happy with how that came out. I even went into the effort of turning the ends of the bolts so that you didn't see any details on them.
Oh, wow.
Yeah.
And it's not, there are many bolts to do that too as well.
Yeah, so these are M10, and I think there was something like 40 of them. So what I made was I made a little, you say about the feet, what I actually did one day, I just put a ruler on the floor and I measured my foot, and I got the length about right. When I looked at the width, I got the width way off. But a lot of this was based on my own proportions because that was all I had to work on. It is shorter than me, but the arms are about the length of my arms, and the hands are about the size of my hands. You can say that again, Scott. If we sort of work our way up, the waist section. Now you'll notice there's some discoloring in there. What that was actually caused from was something I wasn't aware of. If you try and anodize with two different grades of aluminium, which is what I was doing, you get discoloring. So what I really should have done is when these sections were water jet, is then water jet a thin bit off the same sheet and use that to weld, so it'd be the same aluminium that come from the same sheet. Because I did it, I got this discoloring. I might try and see if I can just color it some way to hide it, but again, it's a prototype. I kind of know for next time.
It doesn't look bad.
No, to be fair, when I first saw it out the packet, I would admit I said some four-letter words, and I was a bit worried about how that was going to affect it. But actually, now that I've had it like this for a few weeks, I'm quite happy with it. I'm not sort of complaining.
Yeah.
The chest, there's sort of a universal joint I made down there in the middle at the back, and then you've got these two actuators on the front. And I've got some pictures we'll show afterwards of the actual testing. The testing of those actuators.
That's really interesting. So that makes it like a tripod structure where two legs of the tripod can change length, and therefore you can move the top around.
So you'll see at the back there's sort of a shiny pole, if you like. Again, I'll show pictures of that, but that's a turned and milled piece that allows it to bend. So John, next gen is 140 centimeters tall, give or take a bit. So yeah, work our way up. The main circuits are based in the chest, but I've taken some of them out, and partially because then the coding isn't finished, and also so I can actually show them to you, because at the moment I've only got the number that I need. I don't have spares. So if I had spares, it'd be great to have them in and show you, but you'll see. There's a few bits you'll notice that are still the orange prototype color that need replacing. Making our way up. I call this bit the collarbone. You've got 2 speakers and a camera.
Oh, right. Okay. So
It's-
camera in the chest area.
Yeah, so I'm trying to keep as steady as possible. I might now look at this height, switch back to the tripod because that'll be steadier than my hand.
So Scott asked, does his waist flex enough for it to sit in your car? Which just conjured up a vision for me. If you're going through a drive-through or something with a robot sitting beside you.
Yeah.
But
there has been a few times I've considered just sitting it in the seat without the legs. Annoyingly,
Yes.
shoulders are so wide that if I try and stand in front, you might get a sense of how wide the shoulders are.
Yes, it is very big.
Yeah, it's a bit too wide to sit in the passenger seat of my car, annoyingly. I'll talk about the head, then I'll go into the arms. So the head's got 3 servos in the neck. Again, similar layout to the chest with the sort of the 2 points that can move. We've got these ones here that move up and down. And there's a universal joint in the back middle, which you just can't see because its jaw's in the way.
Mm-hmm.
You might just be able to see it in between there. Again, I'm sorry for the camera work. Yeah, I've got that comment a lot, or something like that. Then in the head, there's 10 servos. So there's 2 that move the jaw. There are 2 for each eye, and they're not installed at the moment, but it's actually also got eyelids, and there are 2 for each eye set of eyelid, 1 for each eyelid, top and bottom. So it works out. In total, there's 40 motors in the whole unit.
That's a lot of servos just for the head.
Yeah, so the head and neck, there's 13 servos in total. Making our way just to look at the arms and the shoulders quickly. So beforehand, I mentioned that other shoulder prototype we showed a picture of. That was actually made of 3 pieces of aluminium that were sort of slotted together like so, and then welded. Now, one of them actually, rather than being slotted, it had bolt holes and was bolted in. And the reason for that was, once it was assembled, there was actually no way to get to the stuff inside. And I always thought there'll be that time when you have to do maintenance. In the end, I realised that you could actually design it in such a way that you wouldn't need to remove the side. But I was still worried about the rigidity of it. Those fears were unfounded, thankfully. This is just a sheet of 2mm aluminium that has been bent twice into sort of a U shape, with turned and tapped aluminium rods down the sides, so that makes the square. And then again, more turned bolt heads holding that all in.
Yeah, it's surprising how little material it takes to make a very strong, rigid structure once it's folded and cross-braced. Things like, if you think about something like an aluminium can, I don't know, for those of you who have done it, I mean, an aluminium can feels reasonably strong. You can crush it with your hand, obviously, but it's really surprising if you cut it open and discover how thin the aluminium is. It's like a sheet of paper. It's and once you cut the can open and it doesn't have that cylindrical structure, it suddenly becomes really very weak and floppy. So once you take material and bend it into a shape like this, it becomes much more rigid.
I mean, one thing that I always think about is I don't know if you've ever seen those. You probably, I mean, I'm sure you have, John. Anyone who's maybe watching, you sometimes get support bars in 19-inch racks, which they're sort of more for like putting zip ties on if you want to do a bit of cable management, and they're literally just a bar, if you like, with a load of holes that goes across the length of the rack. But if you just did that, it'd be really flimsy. What they often do is they'll bend the sides, so they might only bend back maybe 5mm, but that bend stops it from just bending in half when you hold it. So it is amazing that when you put a bend into something, you think about girders, like in buildings, how much stronger they are.
Yes, 2 materials at right angles, and it becomes very rigid.
Yeah. Now, on this shoulder, and I should just mention, each side is just a mirror image. So if I show you one, I've basically shown you the other as well. the previous image I showed you, we had these big linear rails that the shoulder ran up. Now there's a few different types of linear rails you can choose from. The ones I chose are pretty strong, so that if you imagine it was held like this, it wouldn't just pull out, and I was worried about sort of weight in this direction. In the end, they were way over the top, so I've used this stuff, which is goes by a lot of different names. A lot of people call it Rexroth, because I think they were the first company that ever produced it. A lot of people nowadays call it 2020 aluminium extrusion, because this is 2 units wide, but a single unit is 20 by 20 millimeters. This is 2040. It's V-slotted, so you can put V-nuts in and make structures. A lot of 3D printers are made out of it now, but you can also use V-wheels, which is runner wheels. So if you think about 3D printing heads, they move left to right, they'll use V-wheels to run in. Inside here, there's 2 V-wheels on each side, so you've got 8 in total across both shoulders. There's a ball screw that runs up the middle, and in the bottom, there is a stepper motor with a limit switch, and that's what does the motion up and down. To move the shoulder in and out, in fact, I'm going to go freestyle here again. If I can get it out. Come on, there we go. So on the inside here, we have another ball screw. As that moves up and down, it pushes at this point, which runs through the whole middle, and that lifts this motor up, which allows the arm to swing up this way. If that makes sense.
Okay. Yeah.
And then put this back in here. There we go. For the arm, we've got a servo here, which gives us that motion. We've got a servo around the back, pushing on the back of the elbow. So as the servo pushes down, the elbow goes up.
Mm-hmm.
Similar motion for the wrist. And then the other part of the wrist there. Oh. And the hands.
The hands are incredibly intricate. That in itself would be a major project for someone.
Yeah, well, what the funny thing about this was that each part of this project was a project in itself. So there were 5 hand prototypes, there were 3 arm prototypes, 4 shoulders, I think 8 heads. You know, only 1 body was made, but it was the 7th design. There was so much that went into all of this. And that was the funny thing. People said, you know, you're a nutter that you're doing this, Josh, but I went on and did it. What we'll do is, if I stop showing that and I show myself again.
Amy likes the hands.
Yeah, well, the hands have been more trouble than I thought they were going to be. I'm not going to lie to you, because of friction between the aluminium. So I've been through 3 different types of servos so far to get them working. And I think I'm going to have to end up redesigning the fingers, making them a bit longer, so I can space out the bolts that go in all the joints and put washers in between. Each finger has 6 aluminium parts, and obviously that's not including the bolts that hold it together and all that. So on one hand, just for the fingers, you've got 30 parts, not including bolts. In total, in terms of water jet parts, there were 110 in next gen, and that was prior to that was 120 parts that were just had to be designed, unfolded in CAD, and made flat, and then those had to be folded
and then folded,
folded, welded, folded again, tapped, whatever else. So there's a lot of work into it. Are you able to show the shared screen thing, please, John?
All right, let's do this now. If I can, hang on.
So I think
how is the layout? Like that is what we want.
Yeah. So I'm trying to just arrange my own screen. As you see it weirdly resizing, that's actually me resizing it on my screen so that I can see it and I can see myself and John as well. This was actually the document I had to submit as the project. So this, believe it or not, the big robot isn't a deliverable in the project, but the whole process of making it is. So I had to make it. But this was the actual project I did. But it's quite, I sort of went through my history and all that stuff. But what is quite good about it, there's the heads you just seen,
Mhm.
is it's got all my prototyping documented. So I'm able to go through and look at this is all the things you ought to consider. What am I going to use for control? Different motors and everything.
So a lot
But
of your design decisions and criteria are captured in this.
Completely. But the beauty of this is, because it's all captured there, we can talk about it more easily rather than me running around trying to find different pictures. I'm going to have to just move this out of the way. Thank you very much. So this was the original thoughts I had for the body. So this body, which sets it apart from the last two I've done, it can rotate at the hips like that. And that was something I was really keen to get in. So my initial designs, which you can sort of see here, were of using ball screws between those points, pulling down with rods to this front bit of the body. So the front body was effectively suspended from a hinge that would be somewhere here at the back. And then this whole thing would be a plate that would rotate. And then I came up with, instead of trying to do it like that, using these captive balls. A lot of people probably have seen them before. They're effectively, it's glitching out a bit here. They're balls that are sort of captured within a housing, and that they're used a lot on the bottom of those mobile computer consoles that you see sometimes in industrial settings. So they've got the sort of computer tower they can move around. And I had the idea of having that sit in a slot. So you'd have a body like this with those in a slot, and it could then rotate. In the end, that idea was completely abandoned for the one you've just seen. It's taken a while to render. This document is over a gigabyte, I think.
Wow.
It takes a while to render. But the body you've just seen is effectively this. It's 3 water jet cut sheets, which are then welded together in place. That is then attached via this central axle to another part, which is made of 4 water jet cut components, which are then welded into place. That's got a rod which sits inside the housing of the waist. Now, all those holes, just looking at, I worked at an assembly table, a couple hundred of those coming at the top.
That's interesting, Scott. So basically, like the whole table would be like a movable surface.
That's quite cool, that. The reason I've got all of these holes you'll see there, and it looks a bit like a sieve, is because at the time I hadn't designed the legs, but I was already sending this off to be cut, and then I was going to be assembling it. So I had to sort of think ahead, and I thought, right, I don't know what legs I'm going to do, but I know that this is the size of the waist. I'm going to cover it in holes, and each one of those holes is tapped to M6. Which was a lot of. I really got a strong arm doing that, tapping all those holes.
Yeah.
And then until I decided that using a drill was a better idea. Don't do that. You're not meant to do it, but I did it. But that meant that I wasn't also limited in my leg design. I also allowed points in case those actuators weren't strong enough. I could put springs in to give them an assist. And again, it was working on the whole. I've got to get this right first time, because I won't be able to remake this. I'm not on a massive budget, and I need to submit this at some point. Then
I can see that you're talking about the size of the document. It looks like you're on page 53 of 248. So you've essentially written a book.
Bear in mind that these pages are spreads, so 2 pages as well.
Yeah.
You can see down here in the middle, that's the seam of the book. So yeah, no, it is a lot, and you can see a lot of it is imagery, thankfully, but there's a lot of text that goes along with it, and all of these, each image is probably 20 minutes of work. Obviously, you might say, "Oh, an image like that's not a lot of work." You're right, but an image like that, the extra minutes taken up in that one, if you get what I mean.
Yes.
My initial idea for those actuators was actually looking at using stepper motors, and I found this really weird stepper motor where its axle is a lead screw. So you wouldn't need to have.
Yeah, I've seen those.
And I came up with some wacky design that was far too big. But in the end, I went to a similar design to what you've just seen. And this is what I was looking at. it's 3D. This was a 3D printed version before I made it out of metal, and I found these really cool ball axles, which were really cool until I discovered they couldn't take a lot of weight, and then I got rid of those, which I was really sad about because I really liked them. But then I was doing testing using power supplies, hanging weights off them with it clamped to a desk, and I was basically testing the motors and the actuators to destruction. I did 3 copies out of PLA plastics. This is all PLA I'm using. Didn't melt a single one until I then made a metal version. The metal, my target was 10 kilograms of force I wanted. The metal one, I stopped testing at 20. So I was very happy I was able to make that. The motors, you see, the motors are only about that big. So I was getting a lot of force out of them with a gear reduction that it already had in its own gearbox. And then I think it was about a 2-to-1 reduction I had with these stainless steel bolts that were fabricated as well. So I was quite happy with that. And then again, it was all the turning of the actual plunger part. Again, I'm sorry that they're pixelated, but it's taken a while for the images to render. And that was the final one that ended up being used, without obviously the 2 joining points added onto it. So that on its own was about 2 weeks just on those chest actuators, which, bear in mind, are only that big, and the whole thing's 40 centimeters tall. The shoulders we already spoke about briefly. These were the laser cut tests that were first. This is the one you saw a picture of earlier, just in a different angle. So I'm using that extrusion I mentioned before to make a oh, thank you, Dodgy, for showing that. I should mention on my YouTube channel, I've got 2 videos of next gen at the moment. One is of it doing face tracking, which we're going to have a demo of shortly. And another one is of it doing a ChatGPT test. So I'll speak more about that in a moment. I don't want to preempt that, but those 2 videos are on there. But don't watch them till after the stream, because otherwise you ruin the surprises.
So everybody should go and subscribe to Dentistries, but stay here for now.
There are more videos coming. I didn't post anything on my YouTube channel for a couple of years, and now I'm trying to start posting on it again. So we've spoken a bit about the shoulders already, so I'm not going to cover that again. Make my way down. It's actually funny. It's not funny. Don't do this if you haven't done a degree yet and you're planning to. But I did do an all-nighter on the last night, as a lot of people do. And a lot of things I had to do was fill in gaps of images. And if you look at these pictures that were added, you see it getting darker and then getting lighter again as the night goes on and it comes into morning.
That is true representation of the all-nighter.
Yeah. And you can also just see here, this is a sheet of 6mm aluminium on the water jet cutter, where it's got some bits cut out. And the reason I've got that picture is you might notice some of those shapes look a bit similar. That sheet cut parts for all 3 robots over its life. So that is the chest plate of the first, that is the chest plate of the second, and that's parts of the waist of next gen. Yeah. So it sort of covered its whole life.
So David just asked, is this document available?
I'm afraid it's not. So this was the document that was actually submitted as part of my degree. I'm not actually sure if I'm allowed to submit it publicly. Not because anything on there is top secret or anything, but because they're the sections I'm not showing. Interviews were conducted with people from industry and education, and while they consented to it being used in sort of this document, they didn't consent to being published into the big wide world. What I might do is see if I can publish an edited one where I would either move those pages or for fun just black them out and make it look all CIA type. We were talking about the hands before. I did actually look at trying to see if I could do a finger splitting on the hands, and I managed to do it, but it just overcomplicated the design. But that was the first assembled hand prototype there.
Yeah,
I think
that is such a project all on its own.
What I will do now is, because this is also an electronics YouTube channel, should we actually talk about some electronics?
Yes, please. Let's do that.
So what I'll do is I'm just going to move my camera background. Do you want to just stop sharing that view, John, please? And
Sure.
I've got a table set up here
Ruth.
at the side. There we go. So I should just mention now what actually Next Gen runs on. It runs on a Jetson Xavier NX, excuse me, which is, for those who don't know, it's effectively a Raspberry Pi on steroids. It's got massive amounts of GPU, and it's great for machine learning and machine vision. When you've got the Jetson, you then can import something called Jetson Inference, which is their framework. And the program it's running, which I'm going to be demoing in a moment, is skeletal tracking. So it's actually, in the old days, you'd have to put markers on you, and you'd have cameras that would track that. This does that without having to put any markers, and you can use any web camera to do that.
Nice.
But that just runs all the brain, and then everything else is connected to a central controller from that. And you're going to see that now. Settings, camera. Right, let's just adjust where we are. That is my microphone I'm having to use because I've been moving around a bit. But there we go. I hope this is okay. I know I don't have a professional setup like John, but we'll run with this. So the controller that's inside of Next Gen is one of these boards here. And then it also has sitting in it one of these as the main hub, if you like. So this is a Teensy 4.0. It's a 32-bit Arduino compatible controller. It's basically every developer's dream because every digital pin has interrupts. Most of them also have PWM. It's got CAN bus built into it. It's got 8 serial interface, UART serial interfaces. So it's a great board. That would sit in this point here. And then I decided in the end to control everything over I2C. So
I know that was. This is a random comment just thrown in. I think that's a reference to a video I did a long time ago where I was using a whiteboard to explain something, and I drew a whiteboard on the whiteboard.
Yeah. So I decided to control everything over I2C. And what I did was I thought to make it easy, I'll use these 9-pin D-sub connectors to connect everything together. Each one is actually exactly the same. It's just doing I2C, but obviously the I2C address is set at the end device, not on this board. And it meant that during setup, I could plug anything into any socket, except I ended up putting these 3 too close together, and I put something in the middle I can't put in the other 2. So it only accepts 3, not 4, but I fixed that on the upgrade. Now, the Teensy is a 3-volt device, 3.3 volt device, but I kept everything else at 5 volts. So I then put in level shifters. I put in the footprints for the actual level shifters, but in the end, because it's cheaper than the components, I bought the level shifter modules that are just easily available, and I just stacked them in there. It's got 6 pairs of level shifters because you've got 2 for I2C. You've then got 4 serial ports here. And then also you'll notice an FTDI connector here with, I know it's not populated, but USB socket. That was for that. All the data that this is sending back to the back to the Jetson, it would also send out of this USB port, and I could plug in with my laptop and get that information without having to connect a screen and a keyboard to the Jetson.
Nice. So it effectively gave you a second debugging channel without interrupting the connection to the Jetson.
Completely, yes. And also, once I've set up, sometimes you put the screen and keyboard away because it's not needed, and that can start being a distraction for people if you've got to then get out in the middle and plug it in, and exactly. I also had here just on the side, this would allow me to interrupt the 5-volt connections to each serial each I2C socket, and also enable and disable them with like effectively a reset line. And that was, again, just, I was thinking when I designed this, it's got to work first time, got a degree deadline to work to. Everywhere that I should. Exactly. So I thought, anywhere I've got power going to something, put a jumper. Because just imagine you've got to search for the trace to break the trace with the end of a screwdriver or something.
Yes.
So even for the serial ports, there that is. And each serial port has 2 1K resistors in line, just in case. And I thought, if worst comes to worst, if that's too high, I can break them out of the soldering iron and solder something else on top. If I blow the teensy, it's in sockets, I can just swap that out for another one. Everything was done as much like that. Now, I have done some revisions of this and some upgraded versions. So this is a mini version I've done, and I've swapped out some of the serial ports for 4P 4C connectors, which I believe is RJ9.
That's a remarkably three-dimensional PCB.
Yeah,
you don't often see one that has parts sticking out like that.
Yeah, well, what I decided to do, I wanted to make a smaller version, and I thought, how small can we make it? So, there's many more mistakes coming, Trev, don't worry. So this board, again, takes the TNC 4.0. I should mention there's also a TNC 4.1, which has all the same pins, but rather than having these extra pins that are on the underside, it's longer, but this one's just a smaller footprint, which is why I'm using it. These are all 4-layer boards, I should mention as well, just because of all the routing. You'll see it's got the the level shifters again. It has got 2 serial ports that are connected to these sockets. However, you might kind of just see there that those who've ever used RJ sockets before will know that you've got 2 rows of holes for the pins to go through, and they're offset by the distance of half a hole. I might have got the offset the wrong way around on the 2 rows. So
I've never done that. Never. You can't claim that I've ever done that.
Yeah, well, I have. So I had to cut off the supporting pins, break the pins out the back, and it works. A revision has been done. This one's got 2 I2C sockets, another serial port here, 3.3 volt I2C, 5 volt I2C, all the power connectors and stuff to interrupt it. And then on the back, look at it this way around, a power in for 5 volts. And I'm going to explain why I know that's 5 volts in a minute.
Oh, and you've used an XT series connector. Yeah. You get the double thumbs up seal of approval from me. It's an XT30.
I'll let you guess where I got the footprint. The USB debug, and then you'll notice there's 2 RJ45 sockets. One of them breaks out with my light switch footprint on the ones I sent John. So it goes ground plus 5 volts, or 12 volts, in this case it's 5 volts, and then 4 switches. Reason is, I thought it'd be great if you needed to make something, you needed to set the robot off to do things based on triggers. You could just plug in, and if you just grounded a cable, it might react to something. So it was an easy way of building an interface. The other one goes off to an indicator board, which it just happens to have 8 connectors. So I thought I'll just use RJ45 because it's easy to swap in and out when there's a mistake. So yeah. Also, on almost all of the boards, I put these 2 sort of white boxes with serial number and ID. So I was trying to take the view that I'm hoping to manufacture next gens, and I thought keeping track of circuits that might break and stuff like that, give each one a serial number, and that way you can keep track of it.
Well, that little comment has just opened up an enormous rabbit hole that we could dive down. There was a comment maybe half an hour ago, which I didn't bring up, which is, how is this a commercial project, a viable product? And there was a little bit of chat about how this is a university project. It is showcasing skills. It doesn't necessarily have to be a product. But now this sounds like you do want to be making it. Did you want to talk about that, or is that something to
I will
cover later?
About that, but I'm going to talk about that at the end of the stream, if that's all right.
That sounds good.
I will come back to that, don't worry. And that means everyone's got to stick around to the end to hear it now. I will also just show you, I have made a longer version. I haven't actually finished placing all the parts on this, but I've got it. This one's got extra I2C sockets. It's got the USB debug. And rather than having all the serial ports broken out, I left them all together so I could put another board on top if I wanted to. and it's also got space here for the DMX module, rather than having that on a separate board that plugs in. So it's kind of an all-in-one contained board. Originally, I was going to put this on the back of Next Gen as an upgrade, but decided not to now. But I do want to start selling these circuits so that other people who are making robots can use them. On the anyone who's ever been on Star Tours, the old Star Tours pilots, which is now the DJ at the Star Wars Land, Star Wars Galaxy Edge in Disney. There's a droid builders group on Facebook, and I posted and said, I make these circuits. Would people like it if I sold kind of a group of boards pre-programmed so they could build their droid, put them in straight away, just have to buy the servos and stuff to plug in? And there was some talk about that, so that might be something I'll be looking at doing in the future. But so that's like the control boards, if you like.
Yeah, I think there's going to be some chat that'll continue. Yeah, so they would be useful. So you're absolutely right. What you are building here are building blocks which are for your project, but they can be generalized to other robotics projects as well.
And I think that is a very good analogy of looking at it in terms of with home automation as well. And I remember you saying it in a video once, John, that you started making this stuff because you wanted it, and then you put it on the internet and other people wanted it too. And that's kind of the mindset I'm running with here. Now, I mentioned that was all I2C, so I had to control a load of servos. So I used and I will admit I'm reading it off the chip right now, PCA 9685, which it's an I2C PWM driver.
Yep, for LEDs, but can be used for other things.
And it's also used for servos. Adafruit Maker board, which is probably one of the most cloned boards in the world after the Arduino Uno. And I basically took their schematic, modified it a bit, and worked it into this board. What's great about it is it's addressable. So you can have, 32 of these boards hooked up. Each board can have 6. I realize my focus is way off. I'm sorry about this, everybody. Is the camera a bit fuzzy? I don't know. This is probably as good as it's going to get, so I'm very sorry.
That's all right. We can see enough.
So each board can control 16 servos, and it can have up to 32 of them. Now, the boards that are currently in Next Gen, this is just a spare one. Rather than having these pin headers, they were solder bridges. But this is a second revision, and I decided to switch using the pin headers because I thought, let's say I was at a convention somewhere and one of the boards died. I wanted to be able to swap it out quickly, and I don't want to have to worry about which address is what board. I can just put a jumper in and I know. What I also did is I added an extra LED that is connected to the... I've got an extra LED which is connected to output 15. It goes 0 to 15, so you have 16. And on Next Gen, and you will be able to see it when we turn back around, there's a heartbeat LED. So every second, the pin 13 LED on the TNC flashes. So I know the program's running uninterrupted. I have that same LED flashing on every board. So I know that every board is still receiving data and is still functioning.
Yeah, you can see the communications is live between the different parts of the system.
100%. Now, originally, this is the second, this is 2.1. That was 2. The original version of this board actually had everything working over USB. And I made effectively an Arduino Uno in this shape. It had not a USB socket, but it had a JST connector, which are those pin headers that you can't put down the wrong way. In fact, you're going to see some of those in a minute. But I then switched over to using I2C instead of USB, and it's worked a treat, to be honest. And you'll notice again a 5-volt connector. Now, I know that that's the reason I'm calling that a 5-volt connector is because of
almost a mechanical disaster.
This board. This is the main power board for Next Gen. So there is the old version of this in the chest, which is now working like this. The old version had an MCP23017 in it, and I could individually turn off the relays. I never did that, and I had so many problems with communication with the MCP for some reason. I, in the end, removed it and soldered all of the outputs together and then solder them to the 5 volts connection. So they've just always be on.
Okay. So it
Unless,
just becomes a distribution board.
exactly, unless power was pulled. Now, I'm connecting all my emergency stops over these yellow phono connectors.
Mm-hmm.
So that would be connecting the emergency stop. If I pull that out, all the relays disengage. I use XT60 for 12 volts and XT30 for 5 volts. That way I can never accidentally plug 12 volts into 5 volts and vice versa. Never blow something up by accident. And then here you'll see that there's 4 5 volts on the bottom, 4 12 volts on the top. All the relays that control that. I have kept, even though they're all connected technically, a separate relay for each channel. That's because each relay's got a maximum of 10 amps and it just gives me that overhead. I know 10 amps is probably more than what the cable that's connected can probably deal with, but it just gives me that overhead. I've also got 3 LEDs, 12 volts and 5 volts indication, and if that is on, it means the emergency stop is off. If that is off, it means the emergency stop has been pressed. Then there's also all these pins here. These are pin headers, but they're taller than normal pin headers.
Oh, yes, I can see that. Extended headers to cover the relays.
Exactly. And that allows me that if I ever needed extra power, I can plug another board on top and distribute the power across. So it allows distribution, basically. So that is why I've been calling these 5 volt connectors. I know they're XT30s, but in the world of next gen, they're 5 volts. That's 12 volts. That's emergency stop. So again, it's trying to make it simple, because going on to that commercial aspect, the last thing you want is someone calling saying, I've plugged in the wrong thing on my first day and blown it up. I go, well, so yeah. So again, it's the, I don't like saying the idiot proof, but yeah. 10 amp or 3 will be less likely to fail. No, I agree. And in reality, they're very rarely pulling anywhere near to 10 amps, but it just gives me that overhead. It gives me the overhead that if someone decided to plug 16 servos into one board, it's got that overhead. And I've made sure that all the traces that carry power are very high. I've actually protected everything with diodes on the boards. So you'll see that you've got 2 sets of 2 diodes. One is for the 5 volts in to deal with the servos. The other one is for the 5 volts in through the connector that's controlling the IC on there. So I'm just giving myself that voltage protection, reverse voltage protection, sorry.
Yeah. So
the
Mitchell wanted to know about e-stop.
It's normally closed. And so when I'm not using an e-stop, I actually have this, which is a phono connector where I've wired the 2 pins together.
Yeah.
And I've just split the wire up, so because I always thought if I was ever working somewhere, I could put that on a key ring or something. But that is just when I'm working on it myself. If I don't have an e-stop connected, I can just plug that in, and it acts like an e-stop if I yank it out. And so that would, in this context, be on there, and then pull it out, power's off, effectively.
Yep.
Yeah. Moving on to the exciting board, I guess. For controlling the shoulders and the waist, I was trying to come up with some kind of a motor driver, basically, that needs to drive 4 motors. So in the shoulders, you've got 3 steppers and a servo. So that would be 4 in total. You've got, in the waist, you've got, originally it was going to be 4 actuators. In actual fact, you've now got those 2 actuators in the chest and a 60 kilogram servo on the side of the waist that does the waist rotation side to side.
Did you say 60 kilo servo?
Let's go have a look at it.
6 with a 0. That's a very high power servo.
Let's see if we can just bring this up. There it is.
Yeah.
So it's quite a big servo. If we come around the side back here, you might see it a bit better. There are some cables hanging around. Just try and move those. And it's hooked in directly. Oh, I realise your view is a bit off. There we go. So it's just like a crank, like that.
Mm-hmm. I see, yes. It's just displacing that rotation.
So originally I was going to have 2 actuators here pointing in from each side at a diagonal. And so one would push and one would pull, and then vice versa. But I just decided in the end to stick it with a servo. But so the motor driver, I'll just show you the board unpopulated, which is here, or partially populated, I should say. So just try and adjust. There we go. So my idea was to use the standard stepper drivers, which you can get, I think, at the PCA some things. I don't know. They're red. They're in every CNC and 3D printer.
Yeah,
kit.
they're very common. Yes.
But so it's going to have 4 of those there, each one with a temperature sensor underneath, which would be a 1-wire temperature sensor. This is Atmega 2560, so an Arduino Mega compatible board. Then you'd have 4 steppers out, each with its own temperature sensor. Power in, serial in, 3 ICSP encoders, 2 normal quadrature encoders, 8 switches, 4 pairs for limit switches, and a NeoPixel socket for good measure. Just for people who don't know what an encoder is like a potentiometer, but it's got no end stop, so you can keep spinning and spinning and spinning forever. That's why they're great for motors, because the motor might need to do more than one rotation. And then they come in 2 different types, if you like. So you've got relative position encoders, which means every time the machine is turned on, it starts at 0. And then absolute position encoders, so that if it's positioned at 90 degrees and you turn it off, when it turns back on, it knows it's at 90 degrees. And they're usually done with a magnet, and it will register the position of the magnetic field, and that's how they work. So they're very, very clever. And the absolute position encoders, they're generally, they'll use some kind of communication protocol, whether that be I2C or ICSP. The relative position encoders, they will use 2 phases, which are called A and B, basically. And with 2 phases, you've got 4 positions, both off, A on, B off, both on, A off, B off. And by doing that, you can count steps basically as they spin. Simple version. There's some very good diagrams on the internet that explain it. So yeah, that was the design of the board. And then this was the disaster of the prototype.
The disaster, you say?
Yeah, so in the end, it was running warm. So I 3D printed this mount with a fan on it.
Was that primarily the motor drivers that were getting hot?
Yes. But then I realized I'd have to have a cutout for the motors to be accessible. But then by doing that, I couldn't access where the encoders were underneath. It was an absolute disaster. So I did a redesign of what must be the best looking board I think I've ever done, which is this. So on the top here, you've got the steppers are broken out here. The reason I haven't got pins in there yet is stepper wires come in 4 colors, and I just need to work out which way around the colors are before I put the pins in. These are the pins to be broken out to the temperature sensors. Now, these are 5-volt regulators to allow you to have 2 amps. They're both 1 amp regulators, but combined together they make 2 amps. So you can have servos plugged in down here. And then all of your encoders are passed through to here, and the switches are passed through to here. And I think these are 2mm JSP connectors. And what I decided to do is, rather than having to wire each switch back, is I'd have a switch circuit board like that, just to break it all out, and they'd all come back together. And all this does, there's a fan here which is controlled by a relay underneath, and all this does is bring up all the connections. If I can pull it apart, there we go. So all the connections on those double high pins, see one of the motor drivers installed down there, and you see all the temperature sensors that are underneath. And then for when I want to use a motor, like a DC motor as opposed to a stepper, I designed that, which is just a carrier for an H bridge, and it fits in there. It would take what would usually be the step and direction pins as 2 PWM pins.
Okay.
And it combines the 4 stepper pins into 2 motor positives and 2 motor negatives. And then that all fits together.
Nice.
Thank you.
Yeah, that double stack approach is interesting, bringing the signals up to the top board. So you've got mechanically accessible connectors on the top, and the heavy work being done on the bottom board. It's a good way to get the form factor into a reasonably small footprint just by sacrificing a bit of height.
Yeah, no, 100%. And then for the encoders, so this is the board that would be doing the waste. It's almost identical, so there's less things populated on top. The regulators, instead of being 5 volts, they're actually 8 volts. And that's because that 60 kilogram servo is an 8 volt device.
Mm-hmm.
And then that would break out. So that board, which connects to the actuators in the chest. So there's a lot of boards that actually ends up going into
Yes.
the robot. So yeah, that is it. But what I'll do is I'll just quickly show you where those are placed on the robot, and then we
Sure.
can do the demo, and then we can talk about that commercial thing.
Mm.
So I might go freestyle again, so I apologize again for the wobbly hands. I'll just get this out from underneath. There we go. Which H bridge? That is the L293D.
Okay. One of the classics.
Yeah. So if you can't see what I'm talking about, please just say. I'm a bit far away from the computer now. But back here, there is the Jetson. You can see the activity LED on the Ethernet flashing away there.
Mm-hmm.
On the back here, we've got that control board I showed earlier on with all the level shifters in place. This is just a DMX adapter board. So that's connected to DMX. It's basically an RS485 module on a carrier board. If we just make our way up, that was just a quickly hacked together power board so that I could control that 8 volt servo, and that was just needed for demoing at the uni. Over here, you'll see the last edition of that power board that I showed earlier.
Yes.
Those are the switch distribution boards. There's one on each side, and you'll see all the wires for the arm are sort of cable managed up it, and then they all come together into one big mess.
Umbilical.
Plugged in. Yeah, exactly. And then if I come back around here, in the top of each arm, you have those distribution, so the R2C motor drivers, and you'll see that activity LED I was talking about before flashing away.
Yes.
And that is also right up at the back of the head.
Yes, I can see that.
See there. So that's the sort of where all the boards are. The only other circuits that are in here that I haven't shown is behind the camera, which is an ArduCam board. It's an amplifier for the speakers. It's all just mounted back there.
Mm.
And I've started playing around with an Intel RealSense camera, which is like a Kinect. And
okay, is it a depth
that allows
camera?
you to do depth camera source.
Great.
Yeah, so I'm just going to switch back to the normal camera so you can all see me again. But yeah, so I've got it right here. This is the Kinect camera. The Intel RealSense camera there, so it's quite small, but it's got depth sensing in there as well. So it's very good.
Yeah, the Kinect is much bigger than that. Physically, it's quite large.
Yeah, and so we'll do the demo, and then I'll talk about the commercial thing, which is what that is also related to. And then if there's any other questions in the chat, I'm happy to answer those as well. So if you just bear with me a minute. In reality, I probably want to be standing further away from the robot than I am in this room. I'm slightly limited by the constraints I have. But I'll explain how I've set this up for the demo today.
Okay.
And it's in a very, very long-winded way. But it allowed me to demo sort of two different concepts. The Jetson is doing all the image recognition. It's processing that, and then it's using a protocol called OSC, which is Open Sound Control. It's sending over the network that to another computer, which is running a DMX program. And that DMX program is moving the head. So it's kind of let me demo both sides of the equation just for today. In reality, it does also all work over USB as well, from the Jetson to the Teensy. Just raise this up again a bit so you can see it. I'm trying to put the camera in as best a position I can as possible. Let me see if I can do this again. Sorry about all the switching. Right, there we go. Let's just plug it in. Where did I put my e-stop token?
Yes. It's the opposite of the remove before flight tag. This is the insert before flight.
So I don't know if you can actually see that because you're behind me at the moment.
No, I can see it's tracking.
So what it's actually doing is it's looking for my eyes, working out the midpoint, which is obviously my nose, and then tracking that point. It would, if it could see all of me, remember the camera is there, it would
Yes.
map my entire body. I know a lot of people at the show thought, oh, is this, is it going to mirror me? Sadly, it can't do that because at the end of the day, it's just seeing a 2D image. So it can see if I put my arms up like that, but as soon as I put them forward, it's got no idea what I'm doing. My arms have effectively disappeared behind my fists. Basically vision, because it's only got 2D vision. But as I move around, and then it's set up so that if I just suddenly disappear, it will just reset back to the middle. And so I've disappeared because I'm covering it, and it'll follow me again. And you might have just seen a jaw move up and down there. At the degree show, I set it up so that if a 5-minute timer elapsed and there was a human being present, it would just move the jaw up and down. People reacted in different ways to that. They thought it was trying to talk to them. They actually thought it was thinking. They thought the flashing heartbeat LED was it having some kind of brain. These are all things that just for me told me it was working, but it was interesting seeing how people interacted with that.
Yes, people anthropomorphize these little things.
Yeah. And just so you guys can also see down here, if we go on the handheld, down here is the DMX program running, and you'll see these two sliders are where the head is now. And if I press the introduction button, I hope you can see it. See the jaw go up and down. So that is the DMX program running on there. And as described before, is effectively a series of a lot of sliders.
Oh, right.
Yeah,
it's very much like a soundboard or a lighting control panel.
Exactly. And this is universe 1. And these numbers goes on the screen only up to 33. But there are 512 different channels. And then what I will just do is I'll switch. So I've sadly only got one screen at the moment because here's a top tip for you. Don't step on your screens.
Oh, very sad.
But I will just switch the screen over so it's on the Jetson again. And you can see what it sees when it does the face tracking. Just give it a second. There we go. So I'm just trying to work out the best way of showing you this. It's quite dark. There you go. You can actually see it. So you see me.
Oh, yes, I can see the skeleton overlay.
Yeah, so even if I put my arms up,
the
vision a bit. There we go. It's got this arm more for some reason, but it will map. And if more of me was in, it will map all the way down to my ankles. And what it's following is the midpoint between the orange and the higher red there.
Yeah.
So, yeah. Okay. So I'll just switch back to the regular camera now. No, more one. There we go. So that is next gen.
Very impressive.
Thank you.
Just describing it has taken a significant amount of time. So the amount of work that has gone into all of those subsystems, that's mind-boggling.
Thank you. I'll mention that commercialization thing before if there's any other questions. So next gen has been selected to go to the engineering design show, which is, if you're in the UK and you're able to come, it is in Coventry and is on the 11th and 12th of October. There's thousands and thousands of products there. I think last year or the year before, DigiKey sponsored the cafeteria there. So, it's a massive event. And Next Gen and myself were invited. I'll drop into the chat afterwards the website. I've got a press release that's up on there. I'll drop that in, but then you can just click on the logo at the top and it'll take you to the homepage and everything.
Yeah.
And I'm going to kind of use that as the point to try and launch this. So how much would one of these cost if you're going to buy it? Because I haven't finished working out the prices, between £5,000 and £6,000 if you're going to buy one. Compare that to the nearest most like robot, which I admit is a bit taller. that's £25,000. So it's a significant price reduction. There's also 3 different versions I'm doing. So there's the sort of basic version, if you like, where you don't have a brain in the unit. So you can control it over DMX, or you can plug in with USB to your own computer, write your own programs and control it that way. There's the sort of advanced version where it uses a Jetson Nano, which is so what I've said we've got in there is the Jetson Xavier. That's the top one, if you like. The Jetson Nano is the mid-range one. If the Raspberry Pi was the basic one. Jetson Nano with the camera setup you've got in there, and then the Pro version is the Jetson Xavier set up with the depth camera.
Yeah.
And I'm waiting for the parts. Spatial hearing. So it's going to have a microphone on each side, and if you call it from one side, it would look in that direction, and vice versa.
Yeah. Use a microphone array.
Yeah. And that's all. Tests have been run with ChatGPT, and it works. It's quite interesting, actually. So if you've ever used the ChatGPT API in Python, you can actually give it a prompt. So in my one, it says, you are a robot called Greg. You are this tool made of aluminium. You've got a camera and speakers, and you can do this. And you say to it, tell me about yourself. And it goes on for 5 minutes. It's actually scary. But then I'm trying to push it a bit. And I've got all my friends from my final year. And I've said, right, what's your favorite color? What sport do you like? If you're going to change Greg in one way, what would it be? And I'm now trying to build up a personality so that at the show, people can ask it these questions and it can provide a response. And that is all literally one-liners I'm feeding into the program. And at the shows, I could say to someone, give me a thing to add to it. Cool. Pause the program, add that in.
Do it right there on the spot. Yeah.
And now we've got a new personality trait. So it's actually quite simple to do that. There is also a tabletop version I've done where it's kind of just a head and torso, no arms, but a sort of a shortened, almost squashed torso. And the idea behind that one is that's just for people who are looking to develop the human-robot interaction side. So they may be trying to do more conversational stuff. Or it's a cheaper option if you can't afford the whole unit. And that would also be at the show. But I'm just waiting for the body to be made. I've got the other head, just not in the room at the moment. But yeah, so that is where this is going, and I'm hoping to launch them at the show. And the lead time will be about 6 weeks on each unit.
That 6 weeks sounds tight to me. Now you're talking about 6K pounds, ballpark based on the model. I assume that you've done all of your costings on this, so that it's not just bill of materials. You're having to allow for all of the overheads and time involved in putting this together, which is very significant.
100%. The one thing I need to factor in is actually getting a few pieces of equipment that I don't currently have to produce this, which obviously, and it's that sad fact of you work at a place and you've got all this stuff you can use, and then you leave, and it's like, I've still got all this knowledge, I just don't have the
tools
anymore. And that's the point I'm in. So a little other projects I'm doing at the moment is I'm building my own small CNC machine. And I'm following, if anyone out there wants to build one, look on YouTube for Arduino CNC machine, and many iterations of the same idea will come up. Whatever one you click on is probably the one I'm following. So that's what I'm doing at the moment. And then there's a few other tools here and there I'm trying to source where I can. But that is the sort of line I'm going with that. And I'm also taking on a few clients who want custom robots made for an event if they're launching something and they want one of their characters made. So I'm doing that. But obviously the cost is higher and the lead time's higher on that. And I've got a friend of mine who's an absolute whiz with CAD. There's this new VR CAD they use, and they almost sculpt as opposed to design. If you watch them, it looks like they're doing some kind of martial art when they've got the visor on and they're just going like this with their hands.
Right.
The stuff they produce is unbelievable, and so he's giving me a hand with that as well. So yeah, that's where the future of this project is.
Yeah, there is definitely a difference. Just throwing back to a previous point about use of tools, doing this in the university context where you have access to the machine shop and all of the, who was it? There were many Steves who were helping you. The whole network of assistants, and doing this commercially where you may want 10 chest plates made. So you need to go to an external provider to do the water jet cutting or whatever it is that you need. So
I should actually just say no prices are final.
No. You're not committing to anything. So you're going to have overheads in terms of needing to cash flow the parts and inventory before you can actually start building them as well. So it's there's a lot to keep in mind here.
Yeah, I think what an advantage of being on such a big cohort of all these courses that we spoke about at the beginning is a lot of these people have gone off to work at these companies, and it is like that whole big network when you can say, do you know anyone? They go, our company can't do it, but I know a guy who can. And so it's quite good. And we all added each other on our design Instagrams and all that. And I'll come on to that in a second, Scott. And people are constantly putting on like their Instagram stories saying, anyone know anyone who can do any welding? ? And anyone know anyone who's got this tool and whatever. Scott just asked any DIY kits. I accidentally designed one the other day, which I sent John a picture of actually, which was I took the head off the unit, and again, the whole thing is modular. You could actually just get the head, just get a shoulder, whatever you needed. And I just 3D printed a little stand, and that was what I came up with. I know it's a bit washed out, the image, because you're looking at a phone from a camera. It's a consideration that might be happening. So
I think there would be a lot of interest in that, because a lot of the interaction is with the head and the face. So having just the head on a stand that can sit on someone's bench, it's also a lot more practical in terms of simply having somewhere to put it, because that full-size robot that's behind you right now is physically big. You need somewhere to put that.
You've also seen this room is effects. You know, when I started, this room was a table with a reflow oven on it, and now it's full of 3 full-size robots of varying heights, and it's a constant almost dance trying to get around the room of dodging them, having to rearrange and pull that one over here and all that. No, originally this desktop version was what I was hoping to be this smaller version. But even when I put the head down on the stand, I realized how tall that was on its own. And I thought, wow, the compact version's going to be that much higher. So, no, it's something I'm looking at. And again, once I've got those supply chains worked out, a kit will be something that I'll definitely look into doing. I just need to design, I think, a bit of a better base to hold the electronics. The image I just showed was 4 3D printed plates, effectively, I screwed together. And to weigh it down, I screwed the end off a dumbbell and put it in to hold it down. So it was a quick,
make it secure.
It was a quick put together thing. Just one last thing, because I know we're coming towards the end of the time we have. I'm just going to switch back to the seasickness camera, as I'm going to call it, for a second, because I just want to show one. I've got a few thank yous, and you'll just see on that arm. I'm trying to do this without looking at it. There we go. On that forearm, there's a load of signatures. Those are all the people in the workshop who I mentioned earlier. I got them all to sign it as a thank you to them. Switch back to my front camera. There's a lot of people I wouldn't have been able to do this without, and also all of the sort of amazing YouTube community. Doing electronics and mechanics and all that. I only know how to do a lot of these circuits because I happen to stumble upon the strange YouTube channel of someone drawing a whiteboard on a whiteboard, and I thought this guy's nuts. But then,
and you were right.
Yeah, and I've ended up nuts as well. So there we go. But I watched, it was the live streams, and again, it's what lots of people, including people who are on here now, have done, and then with Discord and all that. So it is. If anyone's looking at trying to do something like this and they're not sure where to start, look at what other people have done. You'll find, if not help, inspiration. And there's always someone who's willing to help, is what I found. There's been many a time over the last year, I've had a question, I've just jumped on the Discord and gone, anyone known about this? And within half an hour, the solution, or at least a point in the right direction,
Yes.
has come up.
Some clues at least.
100%. So yeah. Because I can't see the chat. Is anyone saying anything?
Oh yeah, there were. I've only been half watching it myself. So, Dodgy, when is the first Tier 1 version going to be released?
Give me a year.
Yeah, there have been a couple of funny little things like this.
It's interesting you say that, actually, Mitchell, because when I started trying these chat GPT things, even though I said you are a robot called Greg, it would keep, when I run the test, kind of as a habit, the first thing I'd say is, how are you? Just to get the conversation flowing. And it would always reply saying, as an AI, I don't. So I added, you are not an AI, you are a robot, as a sentence. Never said it again. So it is interesting with these things like ChatGPT, you have to be as straight to the point as possible.
Yes, prompt engineering is the term.
Yes.
So a question Cable Tie has asked a couple of times, but we had a little bit of a discussion about this early on. So Cable Tie.
Yes. The reason I use DMX is 2 reasons. Firstly, it works. 3 reasons. Secondly, it's easy to implement. There's existing modules, existing libraries. The only issue I've ever had really with it is putting TX and RX the wrong way around. That's the biggest issue I've ever had with it.
That's the law of the universe.
I think an issue to the point that on most of my boards now, I use jumpers in case I got them the wrong way around, so I can then just put jumper cables to switch them. The third, final, most important reason for me really is the software I showed you earlier. That's called Q-Lite Controller Plus or QLC Plus. It's free download. The only cost you have is buying, probably off Amazon, which is where I got mine, a USB to DMX dongle, which is effectively, it's got a frosted cover, but it looks like an FTDI chip with an RS485 chip sort of connected together, it uses an XLR socket, which is the standard for DMX. And that's just why having that software for free that anyone can download by a £10 USB connector.
Oh, you've lost audio just for a moment. I think the cable's been bumped out. That's it.
That's why I use it. Also, if I ever took this to an event and they had lighting and sound, I could very comfortably hand it over to their lighting guy and say, runs on DMX, plug it in at the end of your universe.
Interesting.
And all the safety, if you like, of making sure it doesn't go too far, that's all coded on the unit. I don't know why.
Yeah. Okay.
Yes.
So in summary, it has a very low barrier to entry. The actual hardware requirements are quite lightweight. Once you've got that adapter and the free software, you're 90% of the way there, and you can start adding your own devices.
Completely. And the library itself, which is one you can download, off GitHub, and you probably find it in Library Manager, to be honest, is QLC Plus. It's actually called Q-Lite Controller Plus, but if you search QLC, that's letters, Quebec, Lima, Charlie, plus, into Google, it will just come up with them. So, and again, it's free download. It is free. You can get it on Windows and Mac. It claims you can get it on Linux. I have tried and I can't get it to download.
You can't get it working?
But people apparently have, so it is possible. But again, free to use, easy. And then when I did my brief for my project, you have to find a use case and sort of what is the use case for a unit like this. So I can think of a load, but the one that they said was best to just go with for the purpose of the project was education, particularly looking at schools. Now, I said that a school could download free software very easily, and you can come in with the unit and a load of these connectors, and the kids can very easily design their own dance performances and whatever else for the unit to do. And that was another reason for using DMX, as you say, the low barrier to entry. But yeah, the library for Arduino is so easy to use. as well. It's literally reading a channel, and the channel comes up as an integer, and then you can read that integer, do whatever you want with it.
Yeah. Nice.
Yeah.
Okay. So you mentioned classroom applications, and earlier when you were doing the demonstration, you were a little bit, it was very close to you. Do you have any form of force feedback through the actuators?
No, and it's something that I wish I did. I've started to experiment with series elastic actuators, which, if people don't know what they are, usually it can be something like a spring in between the motor that's turning and the actual output, and you're able to measure the deflection of the spring. So that way, if it hits something, it will stop. And that's the key thing with a unit like this. So this unit has a minimum safety distance of 1 meter in all directions. So what was great about doing it at like the degree show that I mentioned was it was put on a plinth, and the plinth was, I'm going to use feet, 4 feet by 8 feet, which is the size of a sheet of MDF. It was a white MDF painted plinth. But everybody knew at the show, don't step on the plinths. So the safety distances were nice and easy. Had they not done that, I would have had to lay down the yellow and black
the striped safety tape
and say social distancing is in place here, just to be safe. So that is a consideration. People always ask me, what are you going to do next? And I hate that question, because there's things I want to change on this, namely the massive shoulders. But on the arms, initially, I think I would add that force feedback, because, being real, the arms are the first things people would probably interact with physically. The head is the first thing that you interact with, but that's not through touch. But the first thing you'd actually touch would be the hands or the arms.
Yes.
So that is definitely a consideration. But being modular, each arm is held on with a single bolt. And so that's an easy swap out, should I then design one.
Okay, great. Cool. Well, it's been a lot to cover in this stream. If anybody has any last minute questions for Josh, please throw them in right now. Yes, and as Gerald says, hit the like, folks. Also, earlier, a couple of times I've brought up Josh's YouTube channel, and I will see if I can find it back in the chat history here. So it's Dentistries is the name of the channel.
And on there, there is the second most recent video is face tracking demo, just like the one you've seen. The most recent video, cheers Mitchell, the most recent video is a ChatGPT test. And every time the robot is thinking, it actually looks up to the corner as if it's sort of having a think. It's using a free version of ChatGPT, so the server time's not amazing. So it takes quite a long time to formulate an answer, but we're working on that. And just on my phone, just here, what I'm doing is I'm just opening up the live stream, but making sure that the volume is off so we don't get any feedback. I've just pasted in, error sending message. Why are you doing that? I think it's because there's a return on it and it doesn't accept returns. Still error sending message. I don't know why. Maybe if I send it to you, John, on here, and then can you drop it in?
Sure.
This is the link to that press release, which will take you to the engineering design show page as well. And then I'm also just going to drop in, this is the page on my website that is related to that unit. And you guys, if you want any more information, it's all on there, or at least as much as I know about it at the moment.
Yeah, great. So I'm just throwing these links into the chat if anybody would like to follow up. Oh, it just says I've got an error trying to post in YouTube as well. Hang on, I'm going to try it through here. There we go. It should be in the chat now. So there is the link to dentistries.com/nextgen with information about this particular robot.
And so, which is the press release. Yeah. Cheers, John.
So Russell has just asked do you have like do you have a schematic of the hand? I
I
assume that's referring to like a mechanical drawing rather than an electrical schematic.
I don't, because of how many individual components there are in the hand. There's no
Oh, we've just
one
lost Josh
diagram.
for a second.
Just lost me. Oh, can you hear
You're
me?
back again. You're back again.
I'm back. There is no one diagram of the hand, sadly, because there's so many individual components. I think each hand has got over 50 components in it. So I don't, sadly, all I've got is images like the one I showed earlier. On my Instagram account, I post some every now and then. That's at Joshua_Dennis_design. And if you scroll back, I posted one about a year ago, which is when I made the hand. But no, I'm sorry, I just don't have one because, as I say, it was designed as sort of, individual components. However, if you search online for robot hand, it is based on a principle that a lot of others have used, which is having a servo lever connected to a rod that, as it pushes, it bends the finger down like that. And that design, there are kits I think you can buy that use that principle. It's quite a well-known principle. Whereas like when you've seen one, you've kind of seen lots of them, if that makes sense.
Yeah.
So if you look online, there will definitely be something you can find that's similar.
Yeah. Okay. Fantastic. Well, I think Pete is going to be very upset if we don't stop for lunch. And I'm very aware that it is now, 2:20 a.m. for you?
No.
So I think we should probably wrap it up.
3:20
a.m.
Yeah.
Oh. So, yeah, thank you so much for going to the trouble of showing us this. And it is an epic amount of work that you have put into these robots. It's not just a robot. There are multiple robots and all of the subsystems. Yeah, oh, there's an alert. That's a notification, I think.
Peter notification. I have been activated.
Peter has been activated. Okay. In that case, we'd better run away. Okay, so thank you very much, Josh. And hopefully you can come back again and show us more progress sometime down the track. It's been great having you on.
It's been great to be back, and thank you everybody for your comments and your questions. I'm sure I'll be watching this back through and going through any questions I've missed and all that. But if you've ever got any question, I'm on the Discord. By all means, drop me a line. I will respond eventually. Don't worry.
Yeah. Fantastic. All right. Thanks, Josh. And thanks everybody else for coming along. And I will be back next week. I'm not sure what the stream is going to be about next week, but it'll be interesting, I hope. Okay. Thanks, everybody. And we'll see you all next time. Go and build something awesome.